Now I would like to invite our next speaker, Younis Al Anqodi, the head of ICT from Transom Handling, to introduce his topic on machine learning for business processes re-engineering based on Lean Six Sigma principles.
Assalamu alaikum. Before we start, when you work with data, the first thing that you learn is thinking. And sometimes it's a wild thinking. I had an experience with one of the CEOs and in one of the companies I used to work with. And his staff number was one number before my number. One day he noticed that and he was saying, look who will be the next CEO. The next day I resigned. So now thinking, having that concept, if we know that Dr. Ali was sitting somewhere here, if I sat in his place, will I be the next undersecretary? Do you have this wild thinking? That's analytics. And when you bring a question that doesn't make any sense, and you make a sense of it, out of it, right? And this is the first thing that you do when you are modeling. So before we start there, I would like to ask, how many of us here unemployed? ما موظف. Unemployed. All right. How many of us here know something about machine learning? All right. That's comforting. Okay, I can talk now. All right. So from today's session, what do we know about machine learning? After some time, machine will be like humans. Where is it? The guy? Machine will be like humans from the last presentation. What makes us human is our feelings, right? Can we mimic feelings from machine? What is a feeling? What is a feeling? Emotion. What is emotion? Chemical? Yes. Can we do that in machine? Of course. So machines today are among us, and to your surprise, some people think that I'm a machine. Anyways, let's move. Now in the presentation, I'll give you an introduction about the business processes. For the unemployed people, business processes are essential for corporates, for organizations. Anything in the organization is linked or governed by a process. So a process is defined as a list or a set of activities that we give it an input and then we expect an output. For example, like requesting a leave, an annual leave. Now it's December, some people will be asking for a leave, right? So this is an activity. Sometimes it hits, right? Sometimes it's very simple. You send it to your line manager and then he approves it. Other times it's very complicated. You send it to your line manager, he will send it to his line manager, then to the head of the unit, then to HR, then to payroll. Complicated. That's why people got the business process re-engineer idea. And the re-engineering, it's in basic, this is the academic definition of it. It's a renovation, restructuring, complete change. But when we ask people in practice, they say any change in a business process, it's an re-engineering. If we eliminated one process, or if we divided one process to two, then that's a re-engineering because we changed the structure of it. All right. There are multiple ways to do the re-engineering, and we will focus on the Lean Six Sigma because now, especially in Oman and the Middle East, it's booming, and lots of organizations are following the method of the Lean Six Sigma. It's not complicated, it's very simple. It focuses on customer. We have a process, and then you will have your customer. Does it add value to the customer? Who will you ask? Who will you ask? You will ask the customer, if it is internal or external customer. Now, for example, in your house, you have your children and you're just about to decide to go out. the processes, they suggest, you approve it. Does it add value to them? They will ask for fun zone, right? Well, regardless what you say, it's fun zone. Then map the value stream, get rid of the junk. The junk is the discussion, all of the discussion that you have. You're spending half an hour convincing them, no, we will go to Mount Jabal Akhdar, Mount Green. Then you will spend 2 hours on the road, boring, right? But they will have their iPads. No, let's say fun zone. Then there is a value and benefit to all of the stakeholders, to the employees, to the customers. It has a financial impact, and there are lots of values of it. Then it's very interesting, right? And the problem, we don't have much of people who know how to implement the Lean Six Sigma. This is one of the companies who implements the Lean Six Sigma, Leanscape, and they say that there is a huge value to implementing Lean Six Sigma, but it comes at huge cost as well. Because when you employ them, you will be paying hundreds of thousands for them. Now, Lean Six Sigma has a 7+1 waste types. They look at the waste types and they eliminate them. It's like defects, overproduction, waiting, when you are waiting on a line, unused talent. You have someone who is talented and has PhD, and you are making him entering data, for example. That's a waste of talent. Transportation, inventory, motion, and extra or overproduction. Overprocessing. And there are lots of details in here. I think the presentation will be shared with you. You will be able to learn from it. Lean Six Sigma is a process. The process is very simple. You define the problem, you measure it, you analyze it, you improve it by implementing or looking at the waste, eliminating the waste, shrinking the process from 10 steps to 2 steps, for example, and then you control. When you deploy it, you control it. Now the idea here with machine learning, that was an idea. We have a process, and we have a process re-engineering, and we have a way to re-engineer a business process. We call it Lean Six Sigma. The machine learning, as we see in Dr. Amjad, he said, I think he left, machine learning is part of AI. AI came in the 50s or before, in the 50s. Machine learning also at that time, but we didn't have the equipment or the hardware to make it work. After 2000, 2010, then we had the equipment, we had more processing power and the computers, then we have it working. And after machine learning, we got the deep learning, which is mimicking the human brain in using the neural networks. And there are types for machine learning: supervised, unsupervised, semi-supervised, and reinforced. Do we know the difference between them? Because I think multiple people discussed them, but I don't think it's clear to everyone. Do we need to explain it? I feel that you are sleeping. It's not lunch yet. Do we need to explain what is the difference between supervised and unsupervised, for example? Classification. All right. So let's leave machine learning. And what is the difference between supervised and unsupervised? That's machine learning. Let's leave machine learning. What is supervised and unsupervised? Teacher-based learning. That's again machine learning. What is the difference between supervised and unsupervised? In supervised, you have someone supervising. You have a team. That team may be a system or a machine learning or people, human people, and you are supervising them to do their job. Unsupervised, you're giving the trust on the team. You don't have a supervisor. You give it the trust to the team, and in this case to a machine algorithm to do the job. And this is the fundamental difference between supervised and unsupervised. Supervised, we will have someone label the data, and we know if we have this input, we will have that output. And then we have a set of data. We will have test a set of data. Then we will have training and test, and then we will be deploying the machine learning algorithm for new set of examples. Then we will ask it to classify and recommend for us. For unsupervised, I have data, big data, but I don't know what's inside it. It's not labeled. It's not, we don't know the output for it. I can't say, for example, this set of data means that. I don't have that. And I don't have the time or the capacity to do that. Then I give it to unsupervised machine learning algorithm, and I'll give it the time. And I'll give it the resources, computers and all of that to do the job. After some while, it will give me some results, but it will take more time. Semi-supervised between them, I have some data and to supervise, and I have other data with no labels on them. Maybe new, not like the labeled data that we labeled. It will give us more output, more labels than the one that I gave it in the beginning. Not like the supervised. The supervised, I will give it all of the labels that I know. It will have only that set of labels to classify. Reinforced, it will be learning by itself. You will give it a rule. You will say, if you see in this data, then the output is that, and then you give it data. It will learn from the data. It's not the case all the time. We have this data, the same set of data, but the output is different. Then it will reinforce based on the learning. For example, Tesla cars. You know Tesla, right? All right. Tesla cars, before 2 months or 3 months, hit a camel. Why? Because it was the first time for it to see a camel. صح؟ هذا اللي يخبرونا. Don't tell anyone. So, after that camel, after that poor camel, have we seen any Tesla car hit another camel? No, it wasn't reported. Why? Because the Tesla car learned that this kind of thing, we shouldn't hit it. It will damage the car. And that car sent the information to all of the other cars. So that's reinforcement. It's changing the rule that we was giving. And this is a set of algorithms around the machine learning, the supervised and unsupervised, and the reinforcement. For our problem today, we're trying to classify the activity in the process as a waste or not waste. That's why it's a classification problem. And here is a set of algorithms that we can use to classify the algorithm. Then, how to do that? We need to develop a model. The model will bring the gap between process science and data science, will close the gap between them. Now we know process science, and this is the data science. And machine learning is part of the data science and the algorithms. We will close that gap, but the model will require data. At the beginning, this was my research. At the beginning, I thought it will be easy, but I spent 5 years researching. It's not easy. There was a guideline to develop a model, and here's the guideline. We defined the business case. We defined the problem. We looked at we selected a case study. When you have a problem, you have to select a case study so you prove that it's correct or not. Then we modeled the machine learning activities. We split the data to test it and to evaluate it, and then we prepared the data. Now we are ready to implement. The proposed model will automate part of the process of Lean Six Sigma. At the beginning, define someone in the organization or the business owner will need to define the scope. What do we want to do? We'll give that order to the machine learning, which will measure, will analyze, and will improve the process. But once the machine learning gives this suggestion, the new improved business process, someone in the organization will need to sustain it and control it. How the machine learning model will work, how it will work. The required data. We created this set of data, list of thousands of records of process activities, and then we collected all of this data. We requested the process owner to add more data to the process. The machine learning will classify based on the information. Remember, we're in the Lean Six Sigma, we're looking at the value, right? The data that the business owner will, or the process owner will add, will examine the value of the process. Sometimes we're attached to our process. We don't want to change because people resist change. Today I'm getting lots of papers to sign. I like to sign papers. Tomorrow they will eliminate that. I won't have that luxury of signing papers, right? So people resist. We will resist this change. The model will classify the activity, if it is waste or not, and then will recommend to sustain it or to eliminate it, to delete it completely or to automate it. And this is the strength of this machine learning model. The added value, when we eliminate processes, when we give the recommendation to eliminate a process, the model calculated the activity, the operation cost in terms of time, in terms of money, and in terms of resources. That catch the interest of people because then we will have saving. Then the process performance will be better. Then we will have some saving, some money saving. And from the case study that we did, this was the result. 44.12% of the examined activities were classified as waste. Imagine why. Because of, number one reason, because of bureaucracy. Because 100 people wants to approve a request, where we need only one approval. And there are multiple levels for them. Some of them of the level of a CEO. Who here from you, among you, know the salary of a CEO? What is the salary of a CEO? GBM, he's not here, you can say. Yes, your CEO. Okay, okay. I don't think they are recording, they are not recording. They are filming only. The salary of a CEO varies on the level of the organization of the company. Sometimes it can be 11,000 Oman Riyal, sometimes 25,000 Oman Riyal. Yes, sometimes more than that, sometimes below. Yeah, and some of you don't believe these numbers, but these numbers are real. Here in Oman, we have CEOs who earn more than 23 or 30, 35 Omani, 35,000 Oman Riyal a month, which makes, if he is involved in a process, the cost of that process jumps. If we need his time, 1 minute of his time, to approve a request, then the cost of that process jumps. And that's why we have 115% improvement in the productivity and 35% improvement in the operating cost saving. Imagine. By implementing only Lean Six Sigma, in the traditional way, you will need to bring someone, an expert in Lean Six Sigma, who will sit with you and your team, and who will be mapping the value. They call it the value stream mapping. They will be mapping the value of the process. And then we'll be challenging the team if we need this process or this activity or not. What we're proposing here, what I'm proposing in my model, I call it Anqodi. What I'm proposing here, you don't need that consultant. You can save 200,000 in your pocket, and you can implement my model here. And if you are generous, you will give me 15%. It's okay. Yes, thank you very much.
Thank you, Younis.